So, we just finished reviewing the investment demand curve, a nifty little tool we can use to determine how interest rates affect the amount of investment demanded. Now, we want to see how changes in investment can increase or decrease real GDP by a multiple amount. Here's how to do it. The first assumption is that the economy has room to expand. That is, it is not yet productively efficient. The basic relationship is this: more spending results in a higher GDP, and less spending, and thus more saving, results in a lower GDP. Graphically, this relationship can be studied by placing cumulative income, or GDP, along the y-axis and saving along the x-axis. So, a lower amount of saving will result in more spending, and this spending will multiply over time to create a sort of ripple effect over time. A lower amount of saving, in this case, creates a larger multiplier. To illustrate this idea, let's look at the ripple effect. So in this scenario, we have 4 fish, and they are going to attend the National Fish Bowl, where they plan on spending 90% of their income. This relatively large amount of consumption will create a larger amount of income at each transaction level than if they were to spend, say, only 50% of their income. So the ripple effect comes into play, and the change in GDP produced by this spending is greater. In this way, initial changes in spending produce magnified changes in output and income. Now that we understand the concept behind the multiplier effect,
I have to apologize.
sorry about that, a bit of a goof on our part, but now let's look at the methods to determine change in real GDP. And if you recall from the beginning of the video, we mentioned that the multiplier is basically the change in real GDP over the change in spending. The two equations that you see at the bottom tell us that the cumulative respending effect is determined by increases in income saved. Remember that the MPC and MPS are just slopes of the consumption and saving curves respectively. Therefore, dividing the number 1 by the slopes generates the multiplier. For example, when the MPS is 0.25, the multiplier would be 4, and thus the initial income will increase cumulatively by 4 times that amount. Not to get too math savvy, but the reason that the reciprocals give the multiplier is because of the summation formula for geometric series, which is equal to a over 1 minus r. But as we all know about macroeconomics, this is something that cannot easily be reduced to such simplistic formulas. In fact, these explanatory examples overstate the actual multiplier effect by disregarding consumption spending on imported goods and the effects of inflation. As a result, the actual change in GDP in the United States is much smaller, and it varies to the point that economists disagree on its actual size. And that's about it for our dissertation. We hope you all learned something about the multiplier effect and had a good time all the while. And if you didn't, then just read the textbook. That's what it's there for.